Hello, hello. Am I streaming right now? Let me check once. How do I even check? I do not have actually any idea how to start with this. Yes, me. I'm here to check if I am streaming or not. Stop streaming. Not. View channel. Yes. Yes. Okay, sure. Yes. Yes, I really am time. So happy to say yes, me. So, uh, I think I can start for now. I must remove this part. So, okay. Let me introduce myself first. Let me check it once again if I am streaming correctly or not. So yes. Okay, so let me introduce myself first. Myself Shreyas Kumar. I am a software. I'm an engineering student pursuing electronics and communication engineering at here at NIT Rourkela in India. So I mostly am very inclined toward doing software related stuff. I have been doing that for a year or so now. Recently have been trying to do some embedded related stuff, trying to know what I can explore more in it. So let me remove it. This is actually obnoxious for me. Yeah. So I have made a list of what I want to do cover in this video for now. So now that the introduction is out of the way, let me tell you what things I have been planning for now, because my college is going to start in a week. I think just a week. In a week my college will be starting, and this semester I will be having mostly internships opportunities for now. So I will be having OTs, I will be have to give interviews and all that. So I have to brace myself and prepare for all that stuff. I will be applying for both embedded embedded system roles, and as well as back-end development roles, because these two are the topics I'm familiar with the most. Maybe as time goes, I might study a bit more about cloud and stuff like that. Let's see how it goes, because I honestly have to see what I get first, which field I get my first internship in. So that will determine a lot of it. But for now, that will be the goal of this month or so. And this month I also have, maybe on 24th, I think, next to next week, I think so, I have an OT for Texas Instrument embedded system, which I'm really excited for, because I've been preparing a lot for it. So I will actually for few of these days I will kind of practice my interview this way. I will see how I can I will see how well I can explain these things when I stream. So I have my setup ready for explaining one of my projects. But before that, so yeah, that before going on to that, I want to clarify that will be the goal for this week. So I will be covering stuff like this, whether it will be emulation. I have done a lot of emulation related stuff. So I will be explaining whatever I have done in it, whatever things I have covered in it, line by line, whatever I have written. There might be things which I have forgotten, I don't know. Maybe, obviously there will be, why am I saying I don't know, obviously there will be a few things which I might have forgotten, but that is the point for now, because I want to know how back I'm lagging, how far I'm going. So with that out of the way, let me show you a bit of my resume actually. Let me go to it should not be here actually, wait. I will only show resume for embedded for now, because that is what I am aiming for. But open with Firefox, please. Where is Firefox? Where is, okay, here it is. Open. Yeah. So this is my resume. I'm showing my resume right now so that I can uh, actually show what I have prepared for embedded system, at least for embedded roles. So um, let me go through it. This is my resume, my college and stuff. CGPA 8.5. Actually it is 8.49, but I have rounded it off to 8.5 for now. They have instructed me to change this to 8.4 now, 49 for now. I will be changing it after I am done with this video, when I will be submitting resumes, but for now I will just for this video it is 8.5. So relevant course was this is actually not that fine-tuned. I will say I've made a lot more progress. Actually I've been using the same template over and over and over, so I sometimes forget to change a few things. I will like I can still remove stuff like database management system. I don't really think I need that for an embedded role. I think I might be better with I might be better off putting anything like introduction to IoT, which I covered last semester, or maybe microprocessor lab. It was really great. It incorporated a lot of computer organization and architecture. Not that much, but a little bit was there, so that actually helped me. I think I might mention it. I should mention it, I think so, now that I have said it. But yes, let me go through my projects. So NES emulator, if you guys know NES, NES is a gaming console. Like it was made in 1982-83, something like that, somewhere around that. It is a gaming console which was made by Nintendo. It is Nintendo Entertainment System, not emulation. Nintendo Entertainment System, NES. I'm trying to aim for the original NES, not anything which came after it, like SNES, SNES. I don't know how to pronounce it. So mostly yeah, NES only. So I was working on a NES emulator. I have where do I even start for this? Like I have covered a lot of things in this so far, but the way it started, let me go through how I started with this, because it is rather interesting. I actually was interested in creating something like this, like NES emulator or GB, because I used to like Pokemon a lot, honestly. Stuff like those retro games, Pokemon, Legend of Zelda, and all that stuff. So I always had this interest to make something like this, because I was actually getting very tired with doing same backend stuff again and again, so I thought I should try something new. I did try few things like creating CLI and stuff, but that did not really pique my interest, honestly, at least at that time when I was doing it. So I decided to start creating a NES emulator. This is not May 2025, which I have mentioned over here, May 2025 to present. That is not the time. This is around December 2024, I think so. So around that time I started making this in Go. There still is the repository for it, I think so. I started creating this in Go. Started creating bus CPU for it, but as time progressed, I thought I was not really learning that much from this, because I was really overwhelmed with whatever was being taught to me, honestly. So I decided to give it a break, and actually after a while I really scrapped it out. I did implement a few instructions and all that. It was coming together, I will say that, but I really was not getting the essence of whatever I was creating. I was not really understanding how it is really going to pan out. I don't know how even the CPU worked. I just jumped into it. I think it will work somehow. I actually refer to a YouTube channel for this. Shout out to One Lone Coder. From here I learned about how to make this. That's how I made this. But when I was learning about it, I did not really do that well. I did not study it that well, so I scrapped it out. But as time went on, I started I started doing a lot of other stuff, and I thought maybe I should revisit this. So I actually did not go for Nest directly. I started making something else which would be more like a beginner level thing, for something like an emulator. So I went with chip 8 emulator. Chip 8 is not actually a real microprocessor or something like that. It is kind of actually a real emulator, that is chip 8. It is not like something, some processor named chip 8 existed. No, it was not like that. There is actually directly an emulator chip 8, and for that emulator games were. And this is a very old emulator, not like a recent thing. This is like very primitive one. It goes back to like, I don't know, early 80s or 70s, I do not know honestly. But this is really old, this is really primitive, not that much is going on in it. So for sake of simplicity, I will be covering this chip 8 emulator today for now. So yeah, I will be designing all this stuff. I will show you how I designed, not designing, I will show you how I designed all this, how this all came together, so that I can be more confident about what I am working with. So yeah, that is for the chip 8. After chip 8, I did an NAS emulator in C once again, in May 2025. I really wanted to give C a shot, because they teach us C in college, but not really that much in depth. This is only like surface level. They did not even they did tell about arrays, but they did not even explain how things went around. Like, how are you creating a string with a pointer? I did not understand. They did not explain it. Again, I cannot really fully blame it onto them. It is also a part of my responsibility to understand it. But given that time when I was just in first semester, I did not have that much idea. I was more so stressed about making up attendance and covering up my attendance. Like, how do I attend all classes on time without getting scolded for being late or something like that. I wanted to be on time. That was my main focus around that time. So this is at that time I did not really give that much attention to it, and it was actually not that much. It was really till arrays also, without really teaching anything about pointers. They just had a workaround around it, and we just learned the syntax at that time. But things have changed now. I've been working on this for quite a while, so I can explain this in much depth now. This is actually my first project ever. This is a simple blogging website, but I really wanted this to shine. I did everything which I could at that time. When is this? 2020, June 2024 to January 2025. I just kept on adding. Oh no, I misclicked the link again, and really that domain is I should not say domain. Actually, the domain is pointing to wrong IP address for now. I have not changed it, because I actually changed from my service provider from one to another, so my IP address is now not the same. But again, no, I do not really want this to load, but it will keep on loading forever. I'm trying to fix this as well. I might cover this sometime soon, because I am going to make that website go online for sure. So this is just a simple, not a simple, actually I did a lot for this. This is a blogging website come networking thing. So it does both of this properly. By networking I mean like social networking and all that stuff. So while blogging, you can, like, it is really like that. If you have seen that dev blogs, like that, there is a website, right? dev.to. I don't know how they want me to pronounce this, but yeah, dev.to. I wanted it to be like this now for community around my college, people whom I meet daily. So yes, but this is really, when I started, I did not have that much idea. I knew back in that time. I did it in JS, like the God's language JS, but it was just mind-boggling for me when I started this, because I was learning new things again and again. It was fun actually. This is one of the most fun I had building any project last year, I will say that. So this was really fun. It was mostly mind boggling, because this is where I started it. I just went into this last project at once and for all. I did not know any front end framework. I just started making directly, doing ChatGPT. I know how that code works. Don't get me wrong for that. I know how that code works, but this is how I started learning it. They're using AI models and all that stuff. They gave me a little bit of tutorial. Then they had a nice tutorial on their website as well. That I did follow, and I think that is much better. After a while I switched on to that, and I learned more about Svelte. I think the way they intended me to learn it. So yeah. I did deploy it myself. You understand? This website looks really beautiful. I'll show it once. But yeah, Node.js is a simple backend, and there is not much going on. MongoDB is going on. There is nothing like caching machine going on. There is GitHub action for CI/CD. I have mentioned it, but like it fails for now. This is not in a self-hosted option for me. So let's leave it at that. But yeah, this is all it is. Let's not go for here. So I think that with that I have described my prep so far in brief, right? So I think I can go with the Chipet emulator which I have built. I don't really remember how it, I know the concept, but I don't really remember how the process was while building it. So let me recap it and get some flashback of how it went at that time. Let me recheck if I'm still streaming or not. This is my first time, so I don't really know how it is going. Let me check once. Really remember how it, I know the concept, but I don't really remember. It is a little bit weird to see me talking to YouTube, but yeah. Okay, so I think we can start with it. I might do TSA later on if I have the time, but let me see that. So yes, where do I start for now? Let me actually start from Chipet. This is is this beeper? No, not beeper, Chipet. I think this is it, right? There is not much a separation between addressing modes, and there's not much separation between addressing modes and instruction, like the way these instructions work. There is nothing like that in it, so I think I can directly go with it with this introduction, like the main file which brings it all together, the Chipet CPU. Let me cover whatever is in this struct. So yes, CPU struct opcode. Yes, there is one register for storing opcode for me. There is memory. This is like I don't know, 1 KB memory, I think so. How much it is? 1 KB 1024 4 KB. I mean it is 4 KB. I just missaid that. This is 4 KB, but how much bits it is, I don't really know. 4 KB, this is like let me get my calculator once. See, these are few things which I think I might ruin at interviews, right? These are the things I want to really cover, because I am really not that good with my memory, but I still want to rub it, I still want to make it more finished, if you understand what I mean. So 2 to the power 8. Alright, why is it 2 to the power 8? 16 is 64 KB. 8 is 256. Yes, 8 is 256. Am I back? Am I really streaming right now, or am I really connected? I don't know what happened. 8 is 256. Yes, 8 is 256. I don't remember. what happened really. I think it has to be something with my Ethernet, right? My cable is really like also all these wires are really visible to me with eyes, so I think that there is something with it, because I have been facing it for 1 or 2 months, I think so, 1 or 2 months mostly. So yes, memory is like, I think this is 12-bit memory address, if I have to be, if I'm correct. At least it should be that way, because it is 4 KB memory, right? So for it to be 4 KB, it is this is like, again 4 KB is 409, not here. Why is it? Oh, my caps lock is on. 409, yeah, 4096. This should be it. So this is like 12 kilobit memory. I should actually have, I should open up the wiki for I should open wiki for the chip 8, so that I can really match this stuff. I can revise it more properly. Yeah, I think this is a better starting point for me, right? Chip 8 is an interpreted programming language. Yeah, kind of it is, because yeah, we are writing just just a outer shell for this programming language to work, right? This is, I just want this assembly to work on something and display some stuff, right? I will just provide it some buffers to draw something on the screen. It should draw something on the screen. So yeah, has been used for wide range of devices over time. This is where I am reading it. Chip 8 has been used on a wide range of devices over time. The first community to use chip 8 started in 1970s on microcomputers. Yeah, I did not know. They shared extensions and program in newsletters such as RSCO's Viper for Cosmac VIP users, or Dreamer for Dream 6800 users. What really is 680? Dream 680. I really want to check it, but I do not want to be distracted either. In Viper newsletter, the first 3 issues detailed on machine code for the chip 8 interpreter for VIP. In 1990s, chip 8 interpreters started to be created for graphing calculators. Notable examples include chip 48 and S-chip for HP48. Chip 8 application include original game demos, yeah, and so on. Sure. Extension and variation, no, this is not what I am covering right now. Virtual description, yes, this is where I want to be. Yeah. Memory. Chip 8 was most commonly implemented on 4K systems such as Cosmac VIP and Telmac 1800. These machines had 4096. Yeah, I wrote that wrong over there. I wrote it 4098 at that time. It should be 4096. Memory location, which all of which are 8 bits. Which a byte is taken by each memory location, which is where the term chip 8 originated. This is 8-bit data line. And 12-bit address line, I think so. Yeah, 12-bit, right? Yes, 12-bit. However, the chip 8 interpreter itself occupies 512 bytes of memory space on these machines. 512 bytes. I have to recheck it, like how it is taking up that space. For this reason, most programs written for the original system begin at memory location 512 and do not access any of the memory location below the location. Yeah, this is mostly standard in, I've seen this a lot in languages, like not language, I've seen this in memory being implemented this way for and many things, whether it be the way C program compiles, it creates separate partitions for different stuff. One is for the user mode stuff, I think they call it user mode and kernel mode, I think so. I don't really know. There is ELF like thing. So like there is stuff for for the program to use, right? The actual program which I've written with the code, and the other half is reserved um, for the system to do stuff like this, whatever the operating system or kernel wants to use. There is another half for that. So there are literally two halves for how C works. This is obviously I'm talking about C, not for chipet, but like, yeah, there are separate partitions for how separate partitions for where people want memory to be stored and where they want operating system to do its thing. Same goes for like 8085 processor which we had in our microprocessor lab. Even there was a memory range till that we could not really write any code, we could not really store anything, stuff like that. It might be a really nice idea to include it on another day so that I can cover it. Maybe I will add it to 15. I should add it to 15. It is fine because I will not be covering that much tomorrow, because I have to see a few of my friends. I want to see them. 15 July, and yeah, this is the pattern which I was following. First thing, okay, I am streaming or not? Yes, I am, thank God. I do not have that much trust in this Ethernet cable, man. This really scares me, but yeah. For the 15th July, I will be revisiting 8085 processor and learning some more stuff on 8086, because this is something which I have not done. They only taught us 8085 and they did say some stuff about 8086 in the introductory class, but I don't really remember. It has been a long time since that happened, and it was not really the primary focus of that talk in the introductory class. They really wanted us to know the architecture and stuff. I think they told a little bit about 8086, about how the architecture is better, kind of better, but let's see. I don't really know how it works. I will be checking that out tomorrow. So yeah, I should save it here. It is saved for now. I think I can continue. So yeah, till 512 memory location I cannot really access anything. Do not access, and this is where I am. I do not really have a mouse. I am thinking of buying a mouse and a keyboard. I really am using the trackpad which my laptop has, but I want it because I really want, like, if you know me, I play piano, so it is really nice for me to have something in the way piano is laid out for us. Really, this shoulder level, from the shoulder to elbow, it can just lie on straight and I can write stuff on. I can keep my elbow and this arm on the same level, so it is really comfortable for me that way. It really helps with my posture. I might get a keyboard and mouse someday. I will actually ask my parents. Of course they will allow me, but I should talk with them about this. So yeah, the uppermost 256 bytes are reserved for display refresh. We will be seeing this, I think. I don't really remember, but we might, because I have implemented some display related stuff. Let's see. I might not. Let's see. Uppermost 256 bytes are reserved for display refresh, and the 96 bytes below that, I should highlight where I am reading. 96 bytes below that were reserved for call stacks. Call stack, internal use, and other variable. Yeah, sure. So this is like the stack. What was I trying to say? Yeah, this is where the stack is going, right? I don't think this is 96 bytes must be the highest length for which stack can go out. Obviously these things I don't think you really use anything like heap, but I think I get an idea of how things were working back then. I did not really get much information about people using heap in these these emulators which I was trying to make. But yeah, in modern chiplet implementation, not emulation, where the interpreter is running natively outside 4 kilobytes of memory space, there is no need to avoid lower 512 bytes of memory, and it is common to store font data there. Really, I did not know about that. But interpreter is running natively outside 4 kilobit. Yeah, my interpreter is running natively, so there is no need to avoid lower 512 bytes of memory. I'm really curious about how this works. I really am. Let me first. I will actually use AI because I do not have that much time to Google it up. See, these are the use cases for which I really like AI. It provides a lot of useful insights on this stuff. So yeah, what do I wanted to ask it? Yeah, can you tell me more about how it works for non-native devices? Is it in modern chiplet implementation, where the interpreter is running natively outside the 4 kilobytes memory space, there is no need to avoid the lower 512 bytes of memory, and it is common to store font data there. Can you tell me more about how it works for non-native devices? Like how they utilize the 512 bytes of memory. So in traditional and non-native chiplet implementation, particularly those running on older or constrained hardware, the lower 512 bytes of memory were often avoided due to historical and technical reasons. How here is how memory users typically worked on in those cases. Why the lower 512 bytes are avoided? Original interpreters, Cosmic VIPR. The chiplet interpreter itself was loaded into the lower part of memory, often starting at 0 hexadecimal and 200 hexadecimal. On Cosmic VIP, the machine where chiplet was first implemented. That much we have covered. Oh, non-native, yeah. Font character is the most common use case. Chiplet interpreter requires a built-in font. Yeah, that is the case for a lot of. This is not really interesting to me. Why am I at this one? Let's skip this for now. Yeah, chiplet has 16 8-bit data registers. Yes, we will be covering it. VF register doubles as flag for some instruction, thus it should be avoided. Okay, 16 8-bit data registers. Check 16 8-bit. Data and draw flag, delay timer, key, display, yes, stack 16. Okay, I think this is it. 16. This is the 16 which we are talking about. Yes. Again, I forgot we used to use V for denoting the registers. VF register doubles as flag for some instruction, thus it should be avoided. Yes. In addition operation, VF is the carry flag. Wait, VF register doubles as flag for some instructions. Okay, this is not really special, I think so. Obviously it should be flag for some. There is no borrow flag. Yes, there is no borrow flag. Carry can do both of the work. In draw instruction, VF is set upon pixel collision. Interesting. I don't really understand. I don't really understand if I've implemented this or not. I don't really remember, but this is interesting to know. I will see that I think there is operations for drawing flags and such, or there will be something like this implemented, I think so. Again, this is I have been working on this like for so, like this happened a long time ago, so I really have forgotten it. This is like really helpful that I did this. Let's see. The address register, which is named I, is 12 bits wide, and yeah, 12 bits wide, as I calculated it right earlier this stream. So yeah, it 12 bits wide, and used with several opcode that involve memory operations. The stack is only used to store return addresses where subroutines are called. Yes, so that means we are not really storing any variables and all that such stuff, because in it, the way we use it in NES is like we store the return address as well as the status of the registers in it. So like um, yeah, we really store the state of the registers in the stack as well. So here we are not doing this. Interesting to see, like it will be interesting to see how it goes from there, but let's see. The original RCA 1802 version allocated 48 bytes for up to 12 levels of nesting. I have really no idea what it is trying to say. Yeah, this is new for me. Chip 8 has two timers, both count at 60 Hz till they reach 0. Yeah, delay timer. This timer is intended to be used for timing events of games. Yeah, see, the timers are really like really primitive, that there is not much for me to say about it, because even in NES we don't really have timers in NES. The way timers are implemented is in NES is like we know there is a clock, right? So we really want to waste those clocks, so there are separate instructions for that, so that whenever we are hitting on that instruction with the opcodes and all this stuff, it just says it to like uh, waste this waste this clock, and just move further, go on. And that's how we do. We waste each one by one clocks, and then now we time all that, because we really set the frequency of the program by ourselves, by our own hands, so it should not be an issue. So yeah, we time that NES with really by setting really by wasting those clocks. So here it is different. Here we are really like delaying timer, in that we again the way I think it happened in NES was like there was a continuous loop which was checking in on a certain register as such. So like whenever that register is not checked, it used to just stay in the loop and just to waste a clock and stuff like that. But like whenever we are hitting that register, the value of the register is changed. When it notices that value of the register is changed, the loop for wasting the clock is just exited. So I think that's how it worked over so I think that's how the developers were trying to implement it in NES. But here it is like a delay timer for timing events of the game. Yeah, and sound timer for how sound effects will go. Again, when I will talk about sound for chip 8, it is not really that much. It is just a simple noise. There is like if you know synthesizer, if you have any if you have used any synthesizer, there is just one knob for noise. It is just directly that noise, if you know it. So yeah, it is really just noise. Apart from that, yeah, we will go on to input. Input is done with hex keyboard that has 16 keys ranging from 0 to F. 8, 4, 6 and 2 keys are typically used for directional input here, just like the numpad if you have it in your keyboard, it is same as that, are used for directional input. 3 opcodes are used to detect input. Okay, one skips an instruction if specific key is pressed, while another does the same if specific key is not pressed. Yeah, so that makes sense, because no, there is really no explaining, because one is listening, one is to skip it. one is to not one is to like do something, right? While another does the same if specific key is not pressed. The specific key is not pressed. Yeah. Third key waits for press and then stores it in one of the data registers. So again, let me go through it once again, because apparently my attention span has been reduced by watching a lot of stuff on YouTube, sadly. But yeah, one skips an instruction if a specific key is pressed, while another does the same if specific key is not pressed. Okay, so yeah, instruction is okay, one for skipping instruction when it is pressed, when it is not pressed. Those two are for that. Third is for waiting. Yeah, got it. So third is really trying to waste any clock, I think so. Yes, it is trying to waste clocks. Yeah. So again, no, it won't waste clock because we have timers, right? Yeah, we have timers. There is not nuts. Again, I got a bit confused over there, but yes, graphic and sound. Original chiplet display resolution is 64 x 32 pixel. Yes, and color scheme is monochrom. Yes, and graphics are designed to the screen solely by drawing sprites. Yes, which is 8 pixel wide and maybe from 1 to 15 pixels in height. Again, I don't know. This is mostly programming the programs, right, which we are going to run with chip 8. Again, I should know a little bit more about those programs. I will be honest, I will be looking that up. Hopefully this if I do not make it too late. Again, how far are we? How long is this string? Let me know. I mean, this is mostly programming the programs, right? Okay, we are 40 minutes in, right? Okay, I will quit this. So 40 minutes in, so we have a fair amount of time with us. So I will just add this to my current to do, that added while in the stream. So while in the stream, what have I added? I have added that I need to check how programmers were thinking when they wrote programs for chip 8. Yeah. If I get those keys right. Yeah. In other words, sprite pixels that are set flip the color of corresponding string. Yeah, it is just a boolean and or I think so. Not and or, I mean 0 1 0 1, and it is just XOR. So like we just give it a signal that hey, XOR this, change the value from 0 to 1, 1 to 0, flipping the switch on and off. That is how it goes for all the pixels. And again, there is one thing which I used to get myself confused when I was really working with this chip 8 was, do I really have to draw all those pixels? Like, do I have to keep a loop for drawing those pixels each and every time, or is there like a certain time when chip 8 will tell me, no, this register is set, or like this memory location is set, read this memory location and then draw all those pixels? But no, it is nothing like that. Constantly it is trying to build all those pixels. It is trying to paint all those pixels each and every time. So it is not like a single pixel is switched on and off, so only that single pixel will be rendered on the screen. No, every time each and every pixel will be rendered, which is something I did not know at that time. So yeah, again, this is something which game developers might be knowing a lot more better than me, but again, now that I know. In other words, I have read that much. The carry flag is set to 1 if any pixels are flipped from set to unset when sprite is drawn, and set to 0 otherwise. This is used for collision detection. Again, I did not understand it because I said it too fast. The carry flag is set to 1 if any screen pixels are flipped from set to unset. Here 1 to 0 when the sprite is drawn, and set to 0 otherwise. I did not really understand what it is talking about. Again, Gemini, not Gemini, DeepSeek helped me with this. explain this case for chip 8. In chip 8, the carry flag, often referred to as VF or yeah, plays special role in collision detection when drawing. Okay. Sprite representation. Sprites are drawn using XOR operation. Each sprite is a series of bytes where each bit represents a pixel. Yeah, this is something which we will cover later on in the programming much better. It will be much better represented in the program which I have written, but here it is. Drawing process. When sprite is drawn at coordinate x, y, chip 8 reads each row sprite and XORs it with existing pixel on the screen at that location. If a pixel is off, that sprite is on, the screen pixel is turned on. If the pixel is on, again this is how it worked for chip 8, right? The original chip where we were XORing it. So, but here we are just XORing the buffer which I have. Here it is not like I'm directly drawing on the screen. Here we are drawing into a buffer. Here it is, right? Yeah, this line. 32 cross 64 pixels, not pixels, I think so. 32 cross 64 blocks wide, I think so. Yeah, right. Am I correct or not? Wait. I will just ask it because I am confused, because in NES it does not happen like that. If you are drawing a sprite in NES, it is like we have a block, a kind of sprite thing which has a coarse tuning, like it is in this region of the screen. Let's say this is our screen. We have divided it into 10 sections like this and 5 sections like this. Again, the sprite might take one whole block, but when we will move it over left or right, we do not want that sprite to move like how do I say, we do not want that sprite to move like it was here, this block. Again, this block is completely discarded and it moves to here. No, we do not really want that. We want it to slightly offset itself so that it reaches over the next point, right? So there is in NES, it is like there is a coarse tuning register, if I should say. I don't really know, is it register or memory? Yes, it is a register in PPU. So in NES there is a register. There are 4 registers in PPU for X, Y into the fine tuning and coarse tuning. Coarse tuning are those blocks and fine tuning are just how many offsets, how many pixels of offset do we want to have. So yes, role of carry flag. The flag is set to 1 if any pixel on screen is flipped from on to off. Acha. Got it. It is simple. I did not really understand the way it told. I thought it was like trying to do something contradictory. Am I being misled or something? VF flag is set if no pixel are flipped from during drawing process. If VF, that means sprite collided with something already drawn on screen. That is, some pixel were erased because they were previously set. Okay, got it. This is just for program to know if we have changed something or not, right? Got it. So yes, again, this is nice to know. As previously described, a beeping sound is played when value of sound timer is non-zero. Okay, yes. The opcode table. Chip 8 has 35 opcodes. Okay, I will start with this, but before that I will go to my own code and just map whatever I had over there with here, so that it becomes easy for me to understand. Let me see how the stream is doing, like what is the quality, let me see how the audio is. this is just a simple project last year, I will say that. So this was really fun. It was really connected. I don't know what happened. It started to be
Okay,
created
I
for
think
graphing
the
characters.
audio is nice.
Yeah,
There is literally no problem with audio. I think this will work out. I do not really need to have any complicated setup for audio, but I think this is nice for me. I don't really have to do that much fine tuning, or just I don't really have to do some jugaad, if you know what I mean. I don't really need to have some jugaad. If you are in India, you know what jugaad means. It means just work around in a kind of silly way, yeah. So yes, um, CPU struct key display, yes. So yeah, this is for opcode, yes, for sure. Memory, this we have discussed 16 of registers, which 16 register we are having. The last one is for carry, which was mentioned a lot. I don't really know if I have, let me see if I have had any enums to denote those registers or not. I think not. Wait. Yeah, I do not have any enums to denote how. I do not really have any enums to denote how those registers were working, but let's see. I is for, okay, what is I? Did I forget or something? PC is program counter, of course. Stack is the stack which we are talking about. I don't remember how long it was. 16. You mean 16? Like 16, 32 bytes. Was it 32 bytes stack? 48 bytes. Again, I don't really remember. It should be mentioned over here, right? Somewhere over here it was mentioned about memory. How much memory is there for stack? 96 bytes below that is reserved for the call stack. So is call stack the same thing as what we were having? 96 bytes. Wait. 16 kilobytes. Let me cross check this once again, because this is leading me to confusion. Control C. Again, there has been a thing for me whenever I try to copy something from my Westom, it takes Control Shift C. I use Westom for my terminal. I think it is fantastic. I really do not have any complaints. I press Control Shift C for copying, because I think this is how it should be. Control Shift C should be there for copying, because Control C is just going to shut the program off in many cases. And I can do Control V, I think so, or Control Shift V. I don't really remember. Control V is for, I think, block selection. Yes, a visual block for NeoVim at least. So I think that will be colliding, but at least I can do Control Shift V, right? Yes, I can do Control Shift V. So but when I do it over here, I have to use Control C and Control V. So sometimes I do this and I open the inspector, which is really unfortunate. But yeah, yes, if you explain to me how the call stack is working. How is no, I want to ask if call stack is different from the regular stack. What I mean by that is like, is this really the same stack which is mentioned over here? But like, again, I know this stack is where we refer to when we are like branching to something else. I should not say branching, I think so. I don't really remember if we do that in branching or not. If there is just another go to at the ends to go back to it. Again, I think that branching will also use stack, I think so. Yes, branching should also use stack. Correct me if I'm wrong. I wanted to know if branching also use stack or not. This is a basic question. I should know it, but I don't really know it, because I have forgotten it how it works. I will be revising that for my interview preparation. So yeah, is this the same as the stack which is there in the chip 8 or not? That is what I was trying to think. um, like, is this stack same as the why is this one only 32 bytes? Huh. Chiplet call stack is specifically used for storing return. Yeah, this is how I think it is. uh, for temporary data storage. Okay, this interpreted call stack for something, but it still clears my doubt that call stack is really what I was trying to think of. Again, this is I think it refers to the data structure which we use when like normal programming languages, right? But no, this is not what I was defining. This is what I was thinking of. I think both are same. I think I might have implemented it wrong because I was following a GitHub repository earlier, I think, when I was developing. Let me check into my stars. But yes, somewhere in these stars there should be like chip 8, something like that. Go 8. Again, these were really helpful while learning this. Again, this even I have implemented. Oh wait, I should have shown this to you, right? CD projects. Okay, I will admit I'm going a little bit off track. I'm a little bit going off track, right? That's how you say it. Yeah. I'm going off track right now, so I should not go over there. I will not look into this for now. But yes. Where was I? Yeah, this is not which I was referring to at all. This is what I meant. So both means the same thing. So let's leave it at that. Why chipet? Why only 32 bytes for call stack? Chipet was designed for fairly simple programs. Yes, 16 nested subroutine call were deemed enough. But this is still contradicted, right? Why is this saying there that the 96 bytes below that were reserved for call stack? Okay, internal. So like, I think call stack is different, and for using the memory for internal user variables is considered different. Like, call stack is still 32 bytes only, right? Call stack is still 32 bytes in this, but like all these other things take up the rest of the memory. Got it. So this is where I was confused, but it is clarified now. Again, it should be mentioned somewhere, right? That caused me a little bit of confusion. So yes, that's how it was. This is the same calls. This is for the call stack, right? Then the next is stack pointer. Yeah, fair. If we are having a stack, we will need a stack pointer key. Yes, for the key which we are entering. This is for the. I don't know if inputs are how well these inputs are there, but yes, we have 16 keys ranging from 0 to F. For handling those 16 keys, I have the key thing, right? Yeah, is it 16 key ranging from 0 to F? I want to know what more was there, right? Let me see, because I am a little bit confused on how this keyboard used to work, because again, I did not get really that well of an idea when I was developing this, how this key was working. But now that I'm revisiting it, it kind of gives me an opportunity to go back and look into what I did at that time, right? Because at that time I was really just trying to implement those instruction, whether they were aligning, how do I even pronounce it? If they were aligning aligning. Yes, aligning. If they were really aligning with all the other implementation which were there all over the internet or not. So that was my main focus at that time. But now that I have like really going deep into it, I can see how these things are differentiated. So yes, this is just for, this is really for the keys, right? 16 keys, hex keys. I don't really remember why is it int 8. Why can I not use anything like a boolean or something like that? But we will know. I will check it through once I go into the opcode. I will revise those opcodes. I will know why it is int 8. Let's see. Display, yeah. Draw flag, yeah. Draw flag is telling to like draw a certain value, right? It is not a certain value, but like the way it is there is this display buffer. I think these display buffer memories are interpolated here and there, and when the draw flag is there, um, then only the display flag is drawn. I do not think that is how the case is. I think draw flag is used for something else. Maybe we have the data of what will go in a certain address in the display register stored somewhere in the memory, and when we have that draw flag on, we can grab that data from that specific memory and put that memory into the display buffer, so that the things are displayed really nicely. So that not every time we are just changing this, right? Maybe that is how it works, because I do remember this was their draw. I was trying to draw something with the GPU and stuff. Okay, let's not go over there for now. That is the thing which I will cover at last. But yes, I will cover that in opcode. So before going there, yeah, delay timer, yes, there is not much to it. Delay timer, it resets itself. I think did this mention any a value for delay timer or not? I don't really remember, but yes, I think I read it somewhere. I don't remember how many resources I searched up a lot of resources. Like initially I did I used AI to know basic information, but I searched a lot of places. There were different implementation for it, but I did found this at many places and it used to work. Then beeper is just a function to make sound, really. All that is, it is implemented with using that the game engine which I am using, Abby 10, really nice game engine. It was really simple to implement this, and this yeah, that's it actually. There is not much to add to it. Yeah, really nice framework for implementing games. So like this beeper is just something to make sound. I have added it to CPU, so I can directly take the CPU and that call that beeper to make sound. This is nice. Font set, yes, this is font set. I don't really remember how it works, but like it is like the height of this font is 5 pixel or something. I don't remember. It is like how do I say? Let me write something. It is like a. So like you see right here, it is the height is 5. That's how it is set. So like what F00 means over here is that we are filling this row full up to the like entirely. What 900 means, like we are just going to fill the first and the last one, right? That's how 0 will be made. That yes. So that's how yes. So that's how all these fonts work. Again, one is like there will be 1 pixel at the top, then there will be like the cap which one has. Let me zoom in. Should I zoom in? I will replay this later on and see how much should I zoom in for such that it is really nice to view. But yes, so really nice to view. but yes, uh, so like this is for the cap, and again just one pixel we want to add for to create that stamp for the one. Same over here, and this is for I think the base over that of the one, which we really use for the mostly sans serif, I think sans serif fonts, I think the way they have it is eyes. I yes, over here the way I has that little base at the bottom, same way the one should be a little bit of base at the bottom. That's how it was. So that's how all these are there. Let me check again. Chip 8 font set. Yeah, this is not a chip font set. This is the font set, I think, right? This should be the font set. A B C D E F. Space Invaders. Okay, I got really distracted for a while. I was just lost into it, whatever I built. But whatever it is, font set. I think this should tell how the font is being rendered. Does this? Um, Again, I don't know why specifically these numbers are taken for the fonts. I don't really know. I really copied it from here, I think. Yes, I copied it from here because I just really did not understand why these specific numbers were taken for the font. But yes, let me ask again AI for again for these use cases. I really like to use AI because it just makes things quicker for me. What is how to determine which numbers will be used to create font set for chip 8. Create a font for, so is this how I should write? Because what do you call a single thing in a letter? Should I just call it a letter or symbol? I should call it a symbol, I think. Symbol for a font set for chip 8. Four pixel wide and 5 pixel tall. Yes. One. So okay, so this is just wasted. Is this what okay, this is what it means. The 0 is just wasted, and whatever is left in the binary format, that is the font itself. So like it is 1 it just goes like 1. Okay, this makes it clear, right? This is how it works. So yes, okay, that makes sense, right? CPU in it, there is not that much to it. Again, as we had it in the document, not the document, whatever it was earlier, below like we did mention it earlier that below hex 80 there will just be fonts and all those stuff which program user itself, character and all this. It should be written somewhere. I did read it over here, right? But yes, whatever it was, over here this is the section where data for program will be stored. Emulate cycle. Okay, here is the stuff for emulating each cycle. I will just fetch the higher bit of the operation code from the higher bit of the opcode, and the lower bit of the opcode from the memory directly from program counter. Again, For program counter will just return the higher bit itself, because it is just returning 8-bit memory, right? Yes, it is a 8-bit data line, so it can just return 8 bits. But our address line, our address bus is like 12 bits. So if we want to transfer any data, it will most probably be like 16 bits, with just with the 4 extra bit just wasted. So that's how it works. So we are just taking the higher bits and just or having an OR operation with the lower bits, which are just stored next to the higher bit. Yeah, and we just execute the opcode. I think this is implemented over here only. And the update the timers. Yes, updating timers is like that's why we had int 8, I think so, because each time a cycle is happening, we are updating the timer, so the value really does not cross that much. It is just staying, I think, staying the same, or just increasing, I think. Is this it, right? Or it is just decreasing? C delay timer minus equal to, yeah, it really decreases, right? It just decreases with each and every clock. If hits a certain value, it beeps out the sound. For the case of sound timer, if hits 1, it beeps out the sound. And the program itself is always there to update the timers itself. Not just timers are not just controlled over here, it is also controlled through the opcodes, which we are going to look into. So yeah, there are opcodes to handle those program those timers as well. Buffer, yes, buffer is there for buffer is there to just return the buffer in this form. We have the buffer as like local, how do I say, yeah, local thing, only through private thing, I should say. No, not private, not local, but like kind of situated in this package only. Nothing outside this package can access it, if you know how the naming goes in Golang. So if the variable is starting with a lowercase, this variable can only be accessed inside this package. Like over here, the package is chip8. So if you see over here, there is a beeper package as well, and there is obviously the main package, because this is the chip8 package, this is beeper package, and there should be a main from where we can call the main program. So if you want to access these variables, if you want to access the buffer from main, we cannot really directly access it, so we just have a getter for that. There is a draw function. It sets the draw flag. It sets the draw flag as true or false. Okay, so it draws something and just sets the draw flag and and returns it. Okay, it returns the draw flag and sets it to false. It resets it, kind of. Got it. I was just making it a way too complicated for no reason. But yes, add beeper, yes, function. We will pass in a function. This is like a dependency injection of a function, and we will just attach that function to the beeper. Yes, key, yeah, we will just take the key and just point to it, to that index, and make it 0 or 1. Again, I really said it last time as well. I don't remember why most of the implementation, I should not say every implementation, because obviously I have not seen all this everything, but whatever I was seeing, mostly they used to have int values only, again, which was kind of weird, because we can even use zeros and one, but it's fine. This is just wasting space, but sure. Where was I was to keys, yes. Again, this will only be 0 1. I was better off using bool, I think. Load program. Okay, open it is just like simple file reading, opening a file that, yeah, this I should just write that like normal Golang formatting. I should not. Again, this was around the time where I started using Golang. I did not really understand it all that well, but Again, these are just kind of weird for me. The because I'm now acquainted with using just ERR directly. I don't really like adding the actually a really nice name as a prefix before writing ERR. So again, this is just throwing me off. Again, that was around the time where I did not really know Golang all that well, but yes. Again, this is what is this doing? Length of C memory is less than fstat dot size. I wait again. I want to see this again. Okay. Okay, got it. So if whatever the memory which we are trying to load inside the emulator or whatever chiplet you call it, if we whatever the data which we are going to store in the thing, if that exceeds the maximum size which is possible, again the 512 which is over here, this is just reserved for the program, right? If I am correct, it was 512, right? 200 512, of course. So this much is just reserved for the program to handle itself. This part is what will be the, loaded inside the this is what will be loaded inside the program byte by byte. So if that exceeds it, we are just going to throw an error. When I was looking for other implementation of this, people used to make nice little games out of chiplet, and that is where they used to increase the size of the memory. Again, this is right now 12-bit address line, right? So people used to make it, instead of making it 12-bit, they used to make it 16-bit address line. And that now that we had 16-bit address line, we had access to 64 kilobytes. So people were able to add stories to it, add games with stories to it, and really do cool stuff with it. So it was really nice. So over here it is like this, but in some places there are some games out there which will not run over here, because those games are really designed for the chip with bigger data line. Because as I said, address line, there are 4 bits in the address line just wasted. So if we can utilize that, we can make nice little games out of that. Okay, my throat is just going to give up, I think so. This is, but how far are we in? I don't know how long it has been going. Again, there should be a better way to know how long I have been going on, right? I really, okay, it shows over here it has been 1 hour and 20 minutes. Okay, seems decent. I can go on for 20 minutes more. I think this is the study cache memory. Again, I will not be able to cover this over here. I will not be able to say that much with my voice, because I am really feeling tired. I had a long journey today, coming back to college from my home. So this is out of what I can do. This is not what I can do as of today. I will actually do this off camera, but yes, I can still go through this for now. So again, we are reading the data into a buffer and then copying that buffer into the memory. I think we could have just directly copied it into the memory, I think, but yeah, it is. I think there should be a workaround about it, right? Because again, it started to rain water. Again, this feels really nice because I can feel cold air from here, but yeah, the weather is really nice. I really want to relax right now, but again, this is my first stream. I want to finish something before I go. So again, we are loading that buffer directly into the memory. There might be a better way to just write it off into this but like again the way it is done in C, it has to be done in Golang, I think the same way. But yeah, let's move on from there. For loaded into memory, yeah, the program is loaded. After that program being loaded, we are directly into the op codes, right? So this is where the magic happens. All the magic happens. For again the okay, water is reaching on my hand. um 0 and n is again, I have to look this up. I have to look it up because 0 and n calls machine code machine. Again, this was specifically from Cosmac VIP, not necessary for most ROMs, right? Okay, I think I can just skip this part because I really don't really know how this one was there, because I really have not implemented that. If the last thing of the opcode is F, is that how it should be read? Opcode and F. Okay, we are targeting for a specific bit. Only 0 x00 EE. Okay, the way I proceeded from there was just like going from here, taking each opcodes one by one, trying to do some bit manipulation on the opcode to kind of get a combination which was unique to these specific opcodes. Like if I want 0E00, I would do some bit manipulation around that, bit manipulation around the opcode to get something which was suitable for 0E00E, and then I can do another two cases for the last byte, no, not but last two bytes, whether they are 0 or whether they are E, right? So that's how I have done it, I think. Yeah, this is 0E00E0, and the next one is 000E. When we XOR it with the last one, it will just give 000, sorry, 00E, the second case. So like we are covering both of these cases over here. My ear. So what I am getting from here is that okay, so for if I have an opcode, the way I am going to not distinguish but like segment all these opcode together, because together they are clustered, right? They are just thrown together. So if I want to separate them, the way I had separated them was like I would take each opcode and just read the first byte, first digit itself, the first hex thing. So I will take the first hex and then add it onto the switch case statement. So like this, the first digit 0, first digit 1, 2, 9, A, B, C, D. So yeah, that's how it was. That's how I planned. I planned it. This is how I saw the implementation to be done in many places, and I think this is the way only. I think the way to make a lookup table will be a way. Making a lookup table will be a bit too complex for me, right? Lookup table will not cut it, because in some cases, like whenever you can see n, there are 3 n's over here, there is x, there is y. So this, from an opcode, I want to take these values out, because these are the values which I will be using to do some calculation and stuff, right? So that will be a little bit of an issue if I just make a lookup table for this, because for NAS I had a lookup table, but this is more like a RISC architecture. This is not a sys thing, because the amount of clocks which we are having is just set it, the clocks which it will be taking is defined, and the clocks it will be taking, not the clock but the times in which the amount of times in which we have to read from memory to do certain instruction, it is limited. We cannot it is not like we are first fetching the opcode, now we need to fetch something else from the memory again to to perform certain instruction. No, that is not how this happens in chip 8, right? So that is not how that works. This is more like a risk, right? That is how risk works. Kind of there is more stuff to it, like you can add pipelines for risk B, but yeah, this is just clearing screen. Everything in the display buffer is set as 0. There is not much there to it. Again, if we are clearing it, obviously we want to draw it, so draw flag is true, program counter is incremented by 2. Again, in ideal situation this is not how it should be done, because again this is back then when I did not have that much idea, but ideally this should be how it should be done, because if you want to do something like pipeline, again you want this want the program counter to point it to the next thing, that as soon as we have fetched the current instruction, so that we, while rest of the things work, at least the next instruction can be fetched, if you know what I mean. If you know how pipelining works. Again, I don't think I can explain pipeline in depth right now, but yeah, if you know what I mean. Again, this should be at the first, this should be written first, but again this was old me, I did not know how it worked all that well, but yes. Program counter is, yeah, again remove the top element from the stack pointer, since we are returning from it. Yes, okay, so I think so here I think the stack pointer grows upward, but if we are removing the top element from the stack pointer, that means this stack pointer grows upward. This is contrary to how things work in like my own computer, your own computer where you are watching, right? In those computer the stack grows downward toward the ELF things, whatever those things are there, like the data section in the memory. There is something for the text, I think there is something for BSS from break things, like I don't know, break segment, I don't really remember what we do with that, but like I know that for dynamic memory location we can access that specific section in memory. But yes, rest of it, those the data section and all, except that this stack pointer went from the upper limit of stack pointer and it grows toward this all these segments, right? And in between both of these there used to be heap. But over here it is different, it is not the same way. So that is interesting to me. Program counter is equal to c dot stack pointer. Yeah, sure. In what all these are doing, jumps to address, yeah, program, it is just setting the program counter, there is nothing much to it. One and yes. So if I don't remember if I really explained what this n means. What n means, like it could be any arbitrary value. One, it could be 1 2 3 4. So what 1 3 2 3 4 means is that I want to jump to the memory location 2 3 4 to fetch the next opcode, right? Again, I have been studying pipelines and stuff for computer architecture, so in those stuff we have concepts of hazards, right? So having studying about that, so again I'm seeing all this in new light now that I've studied a bit more over like past 6 months. I think this is a 6-month old project. I finished this 6 months ago. For engineering time period, the whatever the, if you are in an engineering college, 6 months is like a lot. You can study a lot of stuffs in that. And before that I used to just do back end stuff. I did not used to go that much in depth into all these computer related stuff, right? So yes, jumps to address call subroutine at n. Yes, sure. Again, let me understand this first. So there is a function at 0xNNN, right? So we are calling the function at that location. So got it. There is a function defined at this specific location. No, not over there. Over here, there is a specific function defined at this specific this location NNN, and for that location we are from that location we are taking the subroutine, whatever the function, whatever it is, and we are directly calling it. So like in the stack, first of all, before jumping anywhere, the right thing to do, because it is subroutine, right? We are going in for a function. It is not like a if else statement, because if else statement, the things are, if let's say we are having an if else statement, right? So in an if else statement, whatever the values which we had before entering that if else statement, if they change, they will be reflected below, right? But over here this is not what we want. In stack we want not in stack, in when we are going in for a subroutine or when we are calling a function, we don't really what we want is that whatever the program counter which we had earlier, we want to store it somewhere and then go all in on the function itself. And when we come back, fetch whatever progress we had earlier from the stack and just continue processing from there, right? That's how this works. So yeah, again, this is something nice I studied when I got to know really when I was going for C programming and stuff. I understood all this in another new light when I was doing that. But yeah, this is nice to know. I've gone down. Stack pointer, yes, stack pointer will increase. So yes, only skips next instruction. Yeah, these are simple. There is just conditional logic over here. There is not much to do for here. I mean, this is just simple conditional logic. There is not much going on over here. If it is just simple, exactly mapped whatever is written over here, the pseudo code or explanation, it is just mapped directly. There are special implementations over here like drawing sprite and all that stuff, which I could go a lot in depth, but I don't think anyone is expecting me to cover this much in that much depth, right? Because again, these are special use cases. There is not much explanation to do in this. It is just read the documentation and just implement it directly as it says over there. Implement it over here. Not that much is going on. Draw the sprite at coordinate vx and vy. Again, from opcode has xy. We are just having that, and just whatever the pixel we are getting from memory, we are just drawing it. Just continuing with it, right? Let me read it first, so that let me read it once, so I do not have to go through the code once again, like fully in explaining everything. Draws a sprite at coordinate vx and vy that has a width of 8 pixel and height of n pixels. Yeah, each row of 8 pixel is read with bit coded starting from memory location I. Yeah, I does not change after execution. Yeah, again, this is as we mentioned earlier, this is these sprites are stored in a location where the programs are not designed to access, not designed to alter, right? So I value does not change, it should not change as described significant hex and width. Okay, this is not much to say. And for we will draw just each pixel one by one with the memory location I. Okay, I is somewhere, I is something which, I is the, what do I say, I is a register. If we talk, if I mentioned it earlier, but I is a register which just points to a certain memory location for a drawing sprite. So it is just like an iterator, kind of, it works like an iterator. But so we just we point to a certain memory location from I, so that we tell the program that this is the specific sprite which we want to draw, and we just offset it one by one and draw these pixels one by one. There is not really much to cover on that. So like we have I, we just add one value slowly and just move one pixels further, and for each pixel we go to that specific location. I think that is what is being done. For I, we are just iterating. In this what have I done over here? If pixel and I is not equal to 0, then okay, this is the code for setting, and this is the code for the carry flag, right? We want to set, we do not want to set it whenever we want to set it in such a way that it mimics the program the most. Again, I could just do it, I could just go to that specific places with, I could just go to those specific places and just set these values itself, but like it is better to do this way, I think so, because this is the way it works in the program itself. So yeah, we are setting the flag and drawing it later on, and nothing special about it. Draw flag true. Again, now that we have drawn something, we want to add it to draw flag, and this section is for skipping instruction. Yeah, skipping instruction for some key presses. Got it. Okay, and the last one is for timer. Again, this is a very specific use case. I do not really want to cover it because I'm really getting tired right now. But yeah, again, I hope you liked it, because again, this is mostly for my personal reason I'm doing this, because I want to become better at speaking something. I'm really not that good at speaking stuff. I hope my speaking skills become better. I become more confident in going for interviews. Again, that is the aim, and hopefully this gets me more consistent with what I do, because I really sometimes I'm not really consistent. I just take some breaks. Even for GitHub, if you will see, today's activity is like null. There is nothing. I did nothing today. It is just empty. Even for lead code, for a few days I have not been able to do something because I've been preparing for trip. I've been going outside here and there. So yeah, these 3 days are off. I will do something today, but yeah, this is I think where I should call it. So I will be ending the stream here. So yeah.